In problem 39, we have, we want to find the sample size needed to estimate a proportion. So when we're estimating a proportion, that means we want to use this formula to determine the sample size needed for that. So we know from the problem that we are 90% confident, or we want to have a 90% confidence level. The margin of error is 4%, and they didn't give us a preliminary estimate for P. It wasn't even mentioned. So when you don't have a preliminary estimate for P, and that's going to be this P value here in the formula, then we assume that that's 0.5. So we have 0.5 times 1 minus 0.5, and this together makes 0.25. When you multiply that. So if you want to jump right to 0.25, that's fine, or you can just plug into the formula. Then we need to multiply by the value of z, and that's going to come from our confidence level. So I'm going to do that in a second. I'm going to put in the margin of error first, and that's 0.04 squared. So I still need to find that value for c. So let's go ahead and do that over to the side. So I know that I have 90% confidence, or I want to have 90% confidence, I should say. So I look at my normal distribution. If I want to have 90% confidence, then that means that there's 10% left over in the tails. And we want to find what this z value is. This is our negative z value. This is our positive z value. So if there's 10% left over for the tails, I want to split that in half so that there's 5% in each tail, and that makes up our 100% for the whole distribution. So I'm going to use inverse norm, and I'm going to go ahead and just use 5%, and that gives me a negative 1.64, rounded to 2 decimal places. So that's what I'll put in to my formula, and 1.64. Notice I dropped the negative. It doesn't matter whether I put in the negative or not. I'm squaring anyway. It's going to go away. So now I multiply this on my calculator, and I get 420.25, which needs to be rounded to the nearest, not to the nearest whole number. It needs to be rounded up to the next whole number, and that would be 421. So this is telling us how many we need. We need more than 420, so we go up to 421. So let's take a look at the next problem. In this problem, I have, or I want to have a 95% confidence level, the margin of error 3%, and I'm given a preliminary estimate for P. So I can go ahead and use that in my formula, put in 0.27, 1 minus 0.27, times, again I'm going to have to go and find my z value, so let's put in our margin of error, which is 3%, and I square that. So now I need to go and find z. In this problem, oops, keeps moving around on me. Okay, let's try this. Well, okay, so now we have 95% in the middle, which means that there's 5% left over, and that's 2.5% in each tail. Okay, so now I'm going to do inverse norm of 0.025, and that turns out to be negative 1.96. So I go ahead and put 1.96 in, again dropping the negative because it doesn't matter. And this turns out to be 841.3104, and I really don't care what this decimal is because I have to go up to the next whole number, so that's going to give me 842, and there you go. Now for 41, we use a slightly different formula because we want to estimate a mean, and we want to know how large of a sample do we need to estimate a mean. These tend to be a bit smaller than when we're estimating a proportion, the sample size. The sample size tends to be smaller for the mean problems. Okay, so I have 98% confidence. Let's go right to this. And we have 98% in the middle. That means 1% for each tail. I'm not drawing this to scale. I just really want the visual of a middle 98% and what does that leave over for my tails. So we have inverse norm, 0.01, and this turns out to be negative 2.33. All right, so we've got 2.33. The standard deviation was given as 20 in the problem. Over the margin of error is 8. And we square that whole thing. And that turns out to be 33 point whatever. And I make that a 34. And that's how you do those 3 problems.